So this will likely be the last day that we are doing graphing as part of the way that we solve systems. What we're going to work towards basically this whole week is how can we come up with the solutions to this system. Okay, again, system meaning we have more than one equation without graphing them. Okay, and we're going to start that process today. Okay, of being able to come up with our solution without graphing. For your warm up and this opener, when we see a system, remember that we're trying to describe where these lines intersect. Okay, and I'll do this line in red. This is in mx plus b, so I know the slope and the y-intercept. The slope m is the number in front of x. If there's no number there, it's always a 1. So my slope is 1 over 1. Then the y-intercept, b, is at 2. So I'm going to put a dot at 2, and then I have my slope of up 1, right 1. I'm going to do to span the entire graph. We'll connect them. And there's x plus 2. The next line has a slope of negative 2, so negative 2 over 1, and a y-intercept, or a b value, that's at negative 4. So I'm going to put a dot where y is negative 1, 2, 3, 4. Negative 1, 2, 3. I missed that. It's that one. And my slope of negative 2 telling me to go down 2 and right 1. But as I do that, that's not taking me any closer to the line. So that's where I might reverse how I'm using that slope and go up 2 and left 1. And there we go. We found that point of intersection. Okay, so these lines intersect in the graph. So small was that negative 2, 0. Is that what we're seeing? Negative 2, 0. Okay. Right. And so this is a reminder that with systems, we're describing where they intersect, and thus there's an x-coordinate and a y-coordinate to that point of intersection. We will always need to try to find both those coordinates. So again, here in a second, we're going to remove the graph, and we're going to see how can we come up with that solution without graphing it whatsoever. And that's why I kind of warned us before we started. This is picking up a notch. Okay, we're getting into some algebra, some solving of equations, which we haven't done this semester yet. All right, so on top of solving a system by graphing, this next method is called substitution. Okay, this is another way to find solutions or points of intersection. We're going to substitute y or x to create an equation in terms of one variable. That part is really important. That when we do the substitution step, you'll know that you are on the right track if you only have one variable, either being just x or just y. Then we'll use what we know about solving to come up with the value for that variable. And then after we get that variable, we will substitute a second time to find the value of the second variable, depending on if we get x first or y first. And this also means we will still get our 3 possible solutions. We can get one solution, no solutions, or we can get infinitely many solutions. So all of these things will show up, but now they're going to show up without the use of a graph. So as a way to kind of introduce this, let's go back to the same equations that we used in the opener. So we had y equals x plus 2 and negative 2x plus 4. So here's, and we know the solution, right? The solution was at negative 2, 0. Here's how the substitution step works. Both equations are equal to y. And because they're both equal to y, we can take what one of those y's are equal to, and you'll see me circle that, and I can sub that in for y in the other equation. When I say substitute, you can almost think of replace. I'm basically replacing the y in the other equation with what it's equal to, being x plus 2. Okay, and again, I'll use some colors to help us see this. So this first equation will be in red. That's going to replace this y, so the left side of the equation is x plus 2. Then we have the equal sign. And the only thing that got replaced in this second equation was the y. The right side stays the same as negative 2x minus 4. This is that equation that just has one variable, right? Those are only x's. And now I can work on solving for x from here, just like what we did first semester. So remember first semester, I was big on having us always get one side to be 0. We don't need to do that. In fact, now that we've kind of gone through that whole unit, I'm going to take the most efficient way for us to solve equations. And in this case, I like my x's to be positive, so I'm going to subtract x from both sides. So that gives me 2 equals negative 3x minus 4. And then since I have my x's on the right side, I'm going to add the numbers to the left side. So I'm going to add this 4. So I have negative 3x, negative 4 and 4 goes away. 2 plus 4 is 6. So I get 6 equals negative 3x. And then to get x by itself, I need to divide by negative 3. Giving me the x equals negative 2. And that's what we found from graphing, right? That we got an x coordinate of negative 2. So from the solving, we've came up with the x value. Now we just need to figure out what is the corresponding y. So once we get a number here, to get the other variable, we just have to resubstitute what x is equal to. And we can substitute that into any equation that we started with. Okay, it doesn't matter. So what I typically look for is which one is more simple. In this case, I think the x plus 2, but it's not that either of them are that complicated. But I'm going to take this equation. I'm going to write y equals. This x is going to get replaced with what x is equal to, which is negative 2. So that's negative 2 and then plus 2. Well, negative 2 plus 2 is 0. So there's that x coordinate of negative 2, a y coordinate of 0, confirming that same solution that we got when graphing. And thus the solution is negative 2, 0. Okay, remember that since we're describing where these intersect, writing your answer as a point like that is the best way to represent that solution. Okay. So we're going to have a few other systems on the back side of this that get a little more complicated. Before we get into the ones that have fractions or a little more complex, just some quick reminders about what I just did. Okay, so when doing substitution, we need one equation to either be y equals or x equals, meaning get x or y by itself for just one equation. It doesn't need to be for both. Okay, but for one of them, we need x equals something or y equals something. Then we can substitute and solve for the given variable that is remaining after the substitution step. Once you have the value of the first variable, you substitute it back into one of the original equations to get the second. Since we have some idea, why don't you all do 1 and 2 in your groups, where you can see that we have y by itself, so you can substitute that 2 in for y in the other equation, and x by itself, so you can substitute for x in the equation as well. Again, this is not a time to sit there and do nothing. Okay, this is a lesson where I need us to try it, and if you get it wrong, that is okay. Okay, I'm okay with us making mistakes. I want you to make mistakes. Okay, but we've got to try before we even get to any of that. I'll give you a few minutes. I'm going to work them out as well. We're probably going to be doing every single slide on these notes today, so don't work ahead. Just do the problems I'm asking you to work on. Okay. So let's focus first on just making sure we have the substitution step figured out. In the first equation, I'm given that y is 2. So I'm replacing the y in the other equation with that number of 2, leaving us with an x variable to solve for. In the second one, now I'm given that x is negative 2. So I'm substituting in the other equation for the x, and I'm going to solve for the y. Okay, so again, attention to detail, really important here. And again, that's going to continue with all the lessons, that little things, okay, matter. So now after the substitution steps, our task is to solve for the given variable. So in the first equation, trying to get x by itself. There's only one term that has x's, in that equation, and it's on the right side. I'm going to leave it there. I know that I want my numbers to go to the other side, so I subtract 4. 2 minus 4 is negative 2, and that leaves me with negative 2 equals 1/2 x. A lot of students will get there, and they'll be like, oh, I don't know what to do now because of that fraction. Well, if this was negative 2 equals 2x, you would all divide by 2 without even thinking twice. We're just dividing by a fraction. Okay, that's not an easy thing to do. It's a little complicated. And it's not that complicated, but probably need a refresher on that. But since we're allowed to use a calculator, you can just have the calculator do that for you. If you are using a calculator, do it. And I'll explain kind of how I get the value as well. But when I take -2 and I divide it by a fraction, anytime you do a fraction in the calculator, you need parentheses around that fraction. Otherwise, it's very likely that the calculator will do a completely different set of operations. And that gives me -4. So basically what's happening is this -2, it's actually getting multiplied by what? How can I go from -2 to 4 with multiplication? Multiply it by? -2 times what is +4? Yeah. Okay. Or yeah, forget the sign. But yeah, basically what's happening when I divide by a fraction, we're multiplying by the denominator. So when you're dividing fractions, it actually turns into a multiplication problem. Okay. So really this is -2 times 2, which is the same thing as -2 divided by 1/2. Then that gives me x to be -4, and thus the solution of -4, 2. Remember, your answer is always where they intersect. So there's an x coordinate and the y coordinate, and I want to see those answers grouped together like that. All right. Any questions here with number 1? All right, number 2. When I substitute, and again, now I'm substituting for x. Okay, so it's not the y that's changing, it's the x, and I'm solving for y. You want to consider your order of operations, right? Gems, grouping symbols, we have those. So I'm going to do -2 minus 4 first. That gives me -6. Then I'll take that -6 and multiply it by 1/2, which is -3, and then add 5, and I get y equals 2. Solution being -2, 2. Okay. And questions on number 2 here? All right, go and flip this page over. With each one, we're stepping up the level of difficulty just a little bit. Not entirely, actually. Okay, so let's do 3. And with 3, this is more like the warm-up, right? Where I notice that I have 2 equations, right? These would be easy for me to graph and find where they intersect. I notice that they're both equal to y. Okay, James, I'm going to focus up. Okay, they're both equal to y. So I'm going to take what y is equal to from one of the equations, and I'm going to substitute that into y in the other equation. So basically, I'm setting the equations equal to each other, but that's only because of where the y is showing up. So that makes this 1/3 x plus 3 minus 4 equals 2x plus 2. And now this becomes like a problem that we saw first semester. I would always recommend that we simplify both sides, meaning I'm going to distribute this 1/3 before I do anything else. And I'm going to combine any like terms that I might have. So 1/3 times x is 1/3 x. 1/3 times 3 is 1. And then minus 4, and it equals 2x plus 2. I can add or combine like terms with 1 and -4, making this 1/3 x minus 3 equals 2x plus 2. Okay, so I did the substitution step, simplify the left side. Now we're in the same place that we had gotten to with the other problems we've solved here. But what throws a lot of us off is this fraction. What I'm about to show us is one of the most useful things to just get rid of the fraction. Okay, so if I were to read this fraction out loud, when we all agree that that's 1 divided by 3, and what makes it a fraction is the dividing by 3 part. What's the opposite of dividing by 3? To multiply. So what I'm going to do here is I'm going to multiply every single thing in this equation by 3. And that's kind of the trick here. And literally every part in the equation gets multiplied by 3. So this gives me 3 divided by 3x minus 9 equals 6x plus 6. And 3 divided by 3x is 1x. So I get x minus 9 equals 6x plus 6. And now I'm on my way, and I don't have to deal with any fractions. Okay, so now I'm going to get the x's on the one side. So let's subtract x. Subtract x. So negative 9 equals 5x plus 6 and minus 6. So I get negative 15 equals 5x. Divide by 5. And I get the x equals negative 3. After coming up with a value for x, I'm then going to replace the x in either equation. Now again, when you're deciding which one to plug it into, which one is more complicated? The left equation or the right equation? Left is way more complicated, right? Because that's a fraction. So I'm going to plug it into the right one, and I'll be able to come up with the y value a lot quicker. So 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4. Making our solution negative 3, negative 4. Okay. I want to help get started on the next one because it is a little bit tricky. But I'm going to have you do, after we get rid of the fractions, I'll have you take it from there. All right, so first thing I notice, I have one equation solved for y. One equation is solved for x. Okay, so when I do the substitution piece, I can take what y equals, but I need to replace that with the y in the other equation. Okay, so being mindful about where these variables are at are really important here. And again, that's because y equals this 2/3 x minus 6 plus 2. I'm going to replace it with that y in the other equation. So I should only have x's in my new equation. This becomes x equals 3/2, and then times everything that y equals. So that would be 2/3 x minus 6 plus 2, and then plus 3. So this whole part that I'm underlining, that's where the y used to be in the equation. It got replaced with this entire equation here. And it looks messy, right? I've got a couple fractions up there. There's a lot going on. Now we're going to follow our grouping symbols, our order of operations, to try to figure out what x is going to equal. So first thing I'm going to deal with is the grouping symbols. So inside the grouping symbols, I have 2/3 that can be distributed. So I'm going to do that first. So it's 3/2 and then times 2/3 x, and that would be minus 12/3 plus 2 and plus 3. Okay, so 2/3 times negative 6. I'm just doing negative 6 times 2 to get negative 12. And then 3 times 1 is 3. That ends up simplifying to negative 4 plus 2 plus 3. Inside the grouping symbols, I can add negative 4 and 2. So 3/2, 2/3 x minus 2 plus 3. All right, now we're going to let our calculator do some help with us, because now I've simplified inside the grouping symbols. Now we're on some multiplication where this 3/2 is going to distribute. So 3/2 times 2/3, I'm going to do that in my calculator. And every time you use a fraction, you need to put parentheses around that in the calculator. So 3/2 in parentheses times 2/3. Anybody want to take a guess on what it might be? It's going to be 1. Because you end up getting 3 times 2 is 6. 2 times 3 is 6. 6 divided by 6 is 1. So that's 1x. Then I'm going to do 3 halves times negative 2, which is negative 3. So this is x minus 3 plus 3. And negative 3 plus 3, those cancel, and I get x equals x. Well, that's weird. Because now, if I go to subtract x from both sides, I get 0 equals 0. Right? If we have an x and I take an x away, that's 0. Is there anything left for me to solve for here? No, right? There's no variable. When there's no variable for us to solve, that brings in one of our special cases. Okay, and with systems, those special cases are the no solutions and the infinite solutions. The way that we decide whether or not it's no solution or infinite solutions is whether or not this is true or false. Is it true that 0 equals 0? Yeah, right? That's the same value. If I have $0 and you all have $0, we have the same amounts. We're equal. Okay, so since this is true, we conclude that this is infinitely many solutions. So infinite solutions. Okay, and the sideways 8 like that, that's the infinity symbol. And that's where that one comes from. Okay, that one's a little tricky. Here's what I'm going to ask us to do. I want you to try 5 and 6. And again, I just need you to try it. I don't need you to get them right. But you need to figure out how far can you get before you're getting running into some mistakes, okay, before it's getting tricky. Try them both. We'll go over them both. I'm not going to have you show me these to get your homework today. Everyone will get a homework. But I just need you to try it right now. Okay, don't sit there and do nothing. Give me a valid attempt at trying to solve both of those. All right, that's okay. So let's look at both these. Number 5. Okay, a little more straightforward, no fractions. I'm noticing both equations are equal to y, so I'm replacing negative 3x plus 2 with y in the other equation. For sure, simplify that right side, so distribute the negative 3. That's how I got negative 3x and positive 9. Then I combine like terms, the 9 and the negative 4 to get 5, giving me negative 3x plus 2 and negative 3x plus 5. Then I was like, hey, I know I need to get my x's to one side, so I'm going to add 3x. Well, when I add 3x, all the x's go away. When the variables go away and there's nothing left to solve for, you ask yourself, is this a true statement or a false statement? This is false, right? 2 does not equal 5, right? If I have $2 and you have $5, we're not the same. That's not equal. Okay, so this is no solution. So again, that last decision you need to make. If it's false, it's no solution. If it's true, it's infinitely many solutions. Okay, and what does that tell us about these lines? These lines are what? What's the relationship between them? If we say no solution, what do we know about these lines? They're parallel. Good. Yeah, you're right. Yeah, they're parallel. Okay, awesome. Can we see that right here? Could I maybe see even before I even start the problem? What's the slope of both those lines? What's the slopes of both those lines? Negative 3. So couldn't we look at this right away and decide they're parallel before we even start? Yes, you can. Okay, last one. Again, this is one that's tricky. All the fractions are always going to be a little bit tricky. Again, for now, because we're not going to take the time to actually work everything out by hand, this is all us getting used to this on the calculator. And I want you, and you're going to be expected to do this with a calculator. Okay, so the one thing as I walked around, a lot of you that's got sneaky because this equation is solved for x. That equation is solved for y. So when I take what x equals, I'm substituting it in next to the 2/3. So it's y equals that same 2/3. And then this is the part that got substituted in, the 1/2 y plus 1/2. That replaced the x in the equation. You have to pay attention to which variable is which and where they show up. So now when I do the multiplication, and I distribute this 2/3 in the calculator, again, you have to use parentheses. So 2 divided by 3 times 1/2 is 0.3333. You need to be able to go from the decimal version to the fraction. For mine, I press math enter, enter. So whatever calculator you typically use, make sure we know how to do that. And that says it's 1/3. 1/3 is the same thing as 2/6. So I'm going to rewrite this as 1/3 y, just so it's the same. And then I get another 2/6, so another 1/3, and then minus 1. Now, at this point, this is where we can say, hey, we don't like the fractions, so let's get rid of them. And let's get rid of them by multiplying by what we see in the denominator, which is 3. So I'm going to multiply every single thing by 3. That makes us 3y, then 3 divided by 3y, plus 3 divided by 3, minus 3. And a lot of these things simplify. That's 3y equals y plus 1 minus 3. 1 and negative 3 simplifies to be negative 2. And now I can start solving. And I'm going to first subtract y. So I get 2y equals negative 2. And divide by 2 and get that y equals negative 1. So we did all that work just to decide that y is negative 1. We still need to find x. So I'm going to take y equals negative 1. I'm going to substitute it into one of the other equations. I'm going to pick the one where x is already by itself. So 1/2 times 1 plus 1/2. I know 1/2 times 1 is still 1/2. And then 1/2 plus 1/2. If I have a half and I add another half, 2 halves, which is just 1. Again, calculator can do that for you. So 1, negative 1 is your answer there. All right, don't shy away from the fractions. I know it makes it harder.